This is the video for Module 13, Section 7.7, about simplifying complex fractions. First of all, let's look at how to identify complex fractions. When we talk about a complex fraction or a complex rational expression, this is a rational expression whose numerator or denominator or both contain one or more rational expressions. Here's what some of those would look like. In this one on the left, notice that the numerator has one rational expression, the denominator has two rational expressions. So we have rational expressions within a rational expression. The same way with this one, we have one rational expression in the numerator, and in the denominator, notice that we just have a polynomial. In this one, we have one big rational expression in the numerator and another big rational expression in the denominator. And in this last one on the right side, we have two rational expressions in each. So two in the numerator and two in the denominator. We're going to look at two different methods for simplifying complex fractions. So here's method one. Step one for this method is to simplify the numerator and the denominator of the complex fraction so that each one contains a single fraction. Usually in order to do this, that means that we have to get a common denominator in the numerator and add or subtract the fractions there, and then do the same thing in the denominator. Here's an example. For this one, if we want to simplify the numerator, then we're going to look for an LCD for 8 over a and 8. And since 8 is the same as 8 over 1, then that means our LCD is just going to equal a. So we're going to rewrite our numerator so that both rational expressions have a denominator of a. That means that this first one we can leave alone since it already has the denominator we want. For the 8, or the 8 over 1, we have to multiply by a over a in order to get a denominator of a. So that gives us 8 over a plus 8a over a. Now that we have the same denominator, we can go ahead and add the numerators. That gives us 8 plus 8a all over a. So now we've finished simplifying the numerator. Then we would want to look at the denominator. But if we look at it, it's already written as one rational expression since it just has the one fraction bar. So this part is already done. And that would mean that our new rational expression would look like this. 8 plus 8a over a, which is what we got for our new numerator, over 1 minus a over a. Now the next step in a problem like this is to go ahead and divide the fractions. That's why we change this so that we have one rational expression in both the numerator and the denominator, because that means we can invert and multiply with the denominator. So we're going to take the 8 plus 8a over a, which was our numerator, and since we're dividing by 1 minus a over a, we're going to flip it over. That gives us a over 1 minus a, and then our division has changed to multiplication. So now we're going to take this and go through and do the multiplication and then simplify if we can. So this gives us 8 plus 8a times a in the numerator and a times 1 minus a in the denominator. Now can we simplify? Well, notice the 8 and the 8a both have an 8, so we can factor that out. That gives us 1 plus a. There's not any factoring we can do in the denominator. Now that we have everything factored, we see that the only thing that we can cancel are these factors of a. So our final answer would be 8 times 1 plus a over 1 minus a. Let's do some examples using this method. So here our first step is to simplify the numerator. And in this example, that's already done because we already have just one fraction there. Now, if we're going to simplify the denominator, we do have two fractions there. So to simplify it, what we mean is to find the LCD. So if we look at our fractions, our denominators, we have an 8 and a 4. The LCD of those two would be 8. So that means that we would have 1/8. We don't need to change that because it already has the LCD as a denominator. Then for our 3/4, to get an 8 for our denominator, we would have to multiply by 2. So we're going to multiply the numerator by the same thing. Now we have 1/8 minus, and if we multiply our numerators here, we get 6. Multiply our denominators, we get 8. That gives us 1 minus 6 over 8, or -5/8. So there's our simplified denominator. So now we have 3/8, which was our original numerator, and our simplified denominator is -5/8. Now we go on to step 2, which is to invert and multiply. So this is going to be the same as 3/8 times, and now we're going to take our -5/8 and flip it over. I'm going to put parentheses here since we do still have the negative. This would be -8/5. If we go ahead and multiply, then we have 3 times -8 on the top and 8 times 5 on the bottom. Notice that we can cancel the 8's, and here we still have a -1. So that gives us 3 times -1 is -3, and in the denominator we have 5. And this is as simplified as possible. Now let's look at the next example. We already have only one fraction bar in the numerator and one fraction bar in the denominator. So here, the numerator and denominator are already simplified. So that means we can go directly to step 2. We can take our rational expression in the denominator of this and flip it over and turn this into a multiplication. So here's our numerator. And then for our inverted rational expression here, we get 4n squared on the top, 9m squared n to the 8th on the bottom. And let's write all of these multiplied together so that we have one big rational expression. Now we want to simplify as much as possible, so let's do some canceling. If we look at the numbers, we have 7 and 4 on the top and 5 and 9 on the bottom. None of those have any factors in common, so there's no canceling we can do there. Now with the m's, we have an m to the 6th here, and we have an m and an n squared in the denominator. So we could cancel 3 of the m's we have on the top with these 3 that we have on the bottom. We have 1 here and 2 here. So we're going to cancel and make this m to the 3rd, and then we're canceling that m and both of those m's. Now with the n's, we have an n cubed and an n squared on the top, and n to the 8th on the bottom. So we have a total of 5 on the top. We can cancel all of those and cancel 5 on the bottom, so we have 3 left. So let's see what we've got left. We have the 7 and the 4, so if we multiply those together, that gives us 28. And then we have an m cubed, and our n's are all gone. In the denominator, we have 5 times 9, which is 45. And all of our m's are gone. We have an n cubed left. Let's look at the other method for simplifying complex fractions. In this one, we just look at all of the fractions or the rational expressions in both the numerator and denominator and find the LCD of all of them, we're going to use the same example we did for method 1. So in this example, we're going to look at all the denominators we have. 8 over a, we have an a here. For 8, we have an understood denominator of 1. For 1 minus a over a, we have a denominator of a. So the LCD of these three rational expressions would be a. What we're going to do with that LCD is that we're going to multiply each different term in both the numerator and the denominator by that LCD. In the numerator, since we have two different rational expressions, we have to multiply the a by both. This is a lot like what we do when we're clearing fractions. So we have the a times the 8 over a, and the a times the 8 over 1. And in the denominator, the a times the 1 minus a over a. Now let's go through and look to see what kind of canceling we can do. Here we can cancel the a's. Here there's nothing to cancel. And here we can cancel this a, which is a factor, with this a in the denominator. So what we have left is 8 plus, and here we have a times 8, so that's 8a. And notice that our denominators here are both gone. Then in the denominator of our complex fraction, all we have left is 1 minus a. So in this method, multiplying through by the LCD eliminates your smaller rational expressions that are inside of the complex fraction. The last step, as always, is to simplify if possible. So to try and simplify this, factor on the top, because 8 and 8a have an 8 that we can factor out. That gives us 1 plus a. In the denominator, we have 1 minus a. And since that whole denominator is a factor, there are no factors in common between the numerator and denominator. So this one is already simplified as much as it can be. Let's do some more examples of using this method. In this first example, we could use method 1 very easily because we already have only one rational expression in the numerator and one in the denominator. But we're going to do this using method 2 for this example. So we're looking at all of our rational expressions and our denominators. So here we have an 8 for a denominator. Here we have an x for a denominator. So that means our LCD, if we have an 8 and an x, an LCD would just be the product of those two. So our LCD would be 8x. Now we're going to multiply each rational expression by that 8x. So we're taking 8x times our x plus 7 over 8. Then in our denominator, we're taking the 8x times x plus 1 over x. Now we want to do any cancellations that we can. So here we have an 8 here and an 8 here that we can cancel. And in the denominator we have a factor of x here and a factor of x here that we can cancel. Again, look at what happened. Our denominators within the numerator and with denominator have all been canceled out. Now what we have left in our numerator is x times the quantity x plus 7. And in the denominator we have 8 times the quantity x plus 1. Now our last step is to simplify if possible. These are all already factored and there are no factors in common. So this one is simplified already. Let's look at our second example. In the numerator for this one, we only have one rational expression, so we're looking at a denominator of st. Then in the denominator we have two rational expressions. So we have a denominator here of t and a denominator here of s. So we're looking for the LCD for all three of these rational expressions. Since we have st, s, and t, that means our common denominator is going to be st. So now we're going to multiply our one rational expression in the numerator by st, And in the denominator, since we had two rational expressions, we're multiplying each one by st separately. We have st times 3 over t minus st times 5 over s. Now we'll cancel. In the numerator, we can cancel the st, and in the denominator, for our first rational expression, we can cancel the t's, and in our second expression, we can cancel the s's. That gives us 9s squared minus 25t squared in our numerator, and in the denominator, we have a 3s from our first rational expression and a 5t from our second one. Now we want to simplify if possible, and if we look at our expression in the numerator, notice that 9 is a square, so we have 3 squared times s squared, and then here we have 5 squared times t squared. That means, since we have all squares and they're subtracted, that means we can write this as the difference of squares. We can factor our numerator as 3s plus 5t times 3s minus 5t. In the denominator, these two terms have nothing in common, so we can't do any factoring there. Now again, our denominator is one big factor, so we can cancel that factor with our 3s minus 5t in our numerator, which means that all we have left is 3s plus 5t. We've canceled everything in the denominator, so we don't have a denominator left. For these two examples, let's use whichever method looks the easiest. This is a matter of personal preference, but in the long run, if you have an expression like this that has several different rational expressions, probably the easier method to use is method 2, where we multiply through by the LCD. So let's try that one. If we look at all four of our rational expressions, our denominators are 7, 5, 5, and x. And that means our LCD would be 7 times 5 times x, or 35x. So now we're multiplying 35x times each one of our rational expressions in the numerator. And times each of our two rational expressions in the denominator. Now we're going to cancel anything we can. So between 35 and 7, we can cancel a 7. That leaves a 5. 35 and 5, we can cancel the 5, which leaves a 7. Same thing here, we can cancel a 5 here, which leaves a 7. And in our last rational expression, we can cancel the x's. Now what we have left from our first one in the numerator is 5x. From our second one in the numerator is 7x. From our first one in the denominator, we have a 7x that's still left. And from our second one in the denominator, we have a 35. Now we can do some simplifying. In the numerator, we can combine like terms, which gives us a negative 2x. In the denominator, we can factor out a common factor of 7, which gives us 7 times the quantity x plus 5. Now looking at our factors, there are no factors in common, so this one is completely simplified. Now for our second example, again, since this has 4 rational expressions, it would probably be a little bit easier to use method 2, but let's use method 1 for this one instead. So if we're going to simplify the numerator, that means that we need to get a common denominator for 9 over 1 and 3 over x, which would be x. So that means that we want to write the 9 over 1 with the denominator of x. We're multiplying it by x over x. The second rational expression doesn't change, so that would give us 9x over x plus 3 over x. And then if we add our numerators, we have 9x plus 3 all over x. Now let's simplify the denominator. Our LCD between x over 4 and 1 over 12 would be 12. If we want to rewrite the x over 4 with the denominator of 12, we would have to multiply the 4 by 3. So we're multiplying both the numerator and denominator times 3. Our second expression doesn't change because it already has 12 for a denominator. So this gives us 3x over 12 plus 1 over 12. Then we can add our numerators and make it 3x plus 1 all over 12. Our resulting rational expression now is 9x plus 3 over x all over 3x plus 1 over 12. Now we have one rational expression in the numerator and one in the denominator. We're going to take the one in the denominator and invert it. So we're flipping this over. That makes it 12 over 3x plus 1. And that changed this to multiplication. So now we have 9x plus 3 times 12 over x times the quantity 3x plus 1. Notice that we can factor a 3 out of 9x plus 3. What we have left if we factor out a 3 is 3x plus 1. Which means that we can cancel that factor with our 3x plus 1 factor in the denominator. Now all we have left in the numerator is 3 times 12, which is 36. All we have left in the denominator is x. Let's do a couple more examples. This one would be an easy one to use method 1 with, because we already have only one rational expression in the numerator and one in the denominator. So if we use method 1 with this one, all that means is that we just have to invert our denominator and switch our division to multiplication. Now we have 4 times the quantity y plus 10 over 7y. And everything here is already factored and there are no factors in common. So that's our final answer for that one. For our second example, let's use method 2 because we do have 4 different rational expressions here. So let's find our LCD. We have denominators of 1a, a squared, and 2a. So for our LCD, for the a's, we would have to use a squared because that's the highest exponent that we have in any of these rational expressions for a. And we also have to include the factor of 2. Even though it only shows up in one of these, we have to include it. And those are the only factors we had were 2 and a. So our LCD is 2a squared. We're going to take that 2a squared times each of our rational expressions. So we have 2a squared times a over 1 minus 2a squared times 4 over a. And in the denominator, we have 2a squared times 1 over a squared plus 2a squared times 1 over 2a. Remember when you're doing this that you're taking the LCD times each different rational expression. In this case we had 4 different ones, so we have to take it times each one separately. And then we'll do our canceling. There's nothing that we can cancel in this first one in the numerator, so let's just write that as 2a cubed since we have a squared times a. For our second one we can cancel out an a. That leaves us with minus 8a. And then in our denominator, we can cancel our a squareds, which leaves us with a 2. And in our second expression, we can cancel the 2's, and we can cancel an a also, which just leaves us with an a. Now we want to simplify this if possible. And notice on the top, we have a common factor of 2a between these two terms. So if we factor that out, what we have left is a squared minus 4. Now, is there anything else that we can do? Well, if we have a squared minus 4, since this is an a squared, you should automatically look to see whether it's possible to factor this as the difference of squares. And since 4 is 2 squared, then we can factor this as the difference of squares. That gives us 2a times a plus 2 times a minus 2. And in our denominator, we have 2 plus a. Let's rewrite that. Since there's a plus, we can switch the order. Let's write that as a plus 2. And then we'll put it in parentheses since it's our whole denominator, which means it counts as a factor. And we can cancel that factor with our a plus 2 factor in the numerator. And now all we have left is 2a times the quantity a minus 2.